This video is for 11.4 homework. Sorry, I'm getting myself all confused about what number we are working on. So 11.4 homework. So I'm going to do 1 through 11 with you and then have you try just those spiral review ones on your own. So I'll help you set these up, then let you do the math. So one thing we want to remember as we get started, that perimeter is the outside. So perimeter goes just around the outside. We just add. When we're finding the area, that's the inside, and we want to multiply. So perimeter adds, area multiplies the length times width. So are we finding the inside, the squares? Are we walking around to find the perimeter? So number 1 tells us that an engineer is tasked with doubling the length and the width of a city park. So he draws the park on this coordinate plane, and then so we want to find the area before and after. So part A asks us to find the area multiplying before the expansion. So here we're going to find the length of AB. So this starts at 0 and then goes over 1, 2, 3 units. So here we have 3, and then this is 1, 2, 3. So to find the area here, we want to multiply length times width will tell us the area of the park before. Now we want to double the length. So double means times 2. So double the length. 3 times 2 is 6. And we want to double the width. 3 times 2 is 6. And this is going to tell us the area of the park after. So now it asks us, by what factor did the area change? So we know, so we started here and we were 3 by 3. And now we ended up 6 by 6. So we started 3 by 3. Now we're 6 by 6. So we know that, yes, the length got 2 times bigger, but we also know the width got 2 times bigger. So it didn't just, the area didn't double. The area, actually 2 times 2, is the area got 4 times bigger because we made both sides 2 times bigger. So it got 2 times wider, 2 times longer. 2 times 2 is 4. Number 2 has that same city park here, but this time we want to find the perimeter. So we're going to walk around the outside of our park here. So first, we know that this side was 3. Then he walks BC, which is 3. And this is a square, so this is also same as here. So walks 3 more units around to close up the park, 3 more units. So when we do this problem here, this will tell us the perimeter of the park before. So now the length gets doubled. So instead of being 3, we know it's 6. So 3 times 2 is 6. And then the width got doubled is 6. And we need to add up all of that. So 6 plus 6, the bottom is 6. The other side is 6. So all the way around got doubled. So here's our first perimeter. Here's our second perimeter. So how did we get from this answer to this answer? How did we go from here to here? What did they multiply by? This one is different. So our area ended up being times by 4 because it's a 2-dimensional shape. We have a length and we have a width. Perimeter, so yes, I know we walked around, but perimeter, we could actually just unfold this. So we could take this and we could unfold it and say, here's the first side, the second side, the third side, the fourth side, and make it into a 1-dimensional shape. So this answer is going to be different than the area one. So number 3 wants the perimeter, so the outside. So first we need to find our distance. So I'm going to go across first. So how do I get from 0 to B? This is at -3. So we did the absolute value of 3, of -3 is 3. How do I get from 0 to C? That is 2. And we want to add them together because they're in different quadrants. So that will tell us the side of BC, which is the same as AD. So whatever this side is the same here. So write it down twice. So 3 plus 2 is 5. And I want to put it here. So as I'm doing that perimeter, a lot of us make the mistake of just adding up the two sides. If I'm making a fence, that's not going to keep any of my animals in. I need to close the fence and go all the way from start back. So now to go up to C, we went up 5. To go up to D, we went up 1. But we've got this extra space we need to get rid of now. 5 minus 1 is 4. So both of these sides are 4. So now we're going to add up 5 plus 4 plus 5 plus 4 gives us the perimeter. Number 4 wants us to find the length with these segments. So I can notice that these are the same. The Y's are the same. But sometimes I can't visualize where this is. So I can draw myself just a very basic grid. And I need to know I go over 12 to the left, up 4. So negative 12, 4. And then this one is going over 21, up 4. So I can see they're on the same line, but they're in different quadrants. Sometimes just drawing a very basic grid can help us out here. So I'm going to ask myself, so I want to find the distance between. So I'm going over. When I go over, that's my X, right? X, Y. We always go over first. So we're looking for this first number. Over the absolute value of negative 12 is 12. And this one went over 21. So I have this much and this much, and I want to add those together to get the length of that segment there. Hey, here it helps you to draw it out. So negative 6 up 9. And this time we're going negative 6, 13. So this is negative 6, 9, negative 6, 13. So this time our X's are the same. They both went over the same distance. So we need to find this length here. So going up, I can see I went up 9, and this one went up 13. But I can't add them together because I don't have two parts. They're not split by an axis. So we need to get rid of all of this extra, which is 9. So we're going to do 13 minus 9 will tell us the total distance of that segment there. Number 6, right? So we've got these decimals, and that's okay. We can just graph kind of just the right direction. Over 17.1, up 3. So here is 17.1, up 3. Now I'm going to go over farther to the right, 21.4, and up 3. So I just like to visualize where are these. So I can see they're on the same Y because they both go up 3. So I want to know this distance here. So this one went over 17.1. This absolute value is 21.4. And they're in the same quadrant. So I need to get rid of all of this extra. So I'm going to take 21.4 and minus 17.1, and that's going to give me that distance there, right? We don't have two pieces, so we can't add them together. We've got to take away this extra to see what is left. So it's like we had this whole entire line segment all the way to 21.4. But until we get to 17.1, it's like this doesn't exist. So we've got to take that part away. What are we left with? We'll find that when we subtract. Number 7, again, is another length with these endpoints. So draw our grid here. So we're going over negative 3, down negative 12.5. So 12.5. And then, oh, that was a negative. And then this one, we're going over -3. So to the same x over. So I notice my x's are the same. And then we're going down. So -3, -16.5. So I want to find this distance. So how did I get from 0 to the first one? We went down 12.5, which is the absolute value of 12.5. And then to get to the second one, we went down -16.5, which has an absolute value of 16.5. So we need to get rid of this extra piece here. So we're going to take the total, the longer number, subtract the shorter one to get rid of this extra, and that will tell us the distance that is left. Number 8 wants us to find the shaded region. So we want to find the big one, take out the little one. So find this distance here. So this goes over to 6, I can see. And this goes over, there's 5, 6. So total makes this 12. This went up 2. This went down 2. So total is 4. So we want to find the area of this big one by doing 12 times 4. Now we're going to find the area of this smaller one. So over 2 over 5 makes a total of 7. And this one up 1, down 1 makes a total of 2. So I'm going to find the area of the big one. I'm going to find the area of the little inside rectangle, and then I'm going to take away this little one from the big one to see how many shaded pieces are left. So number 9 says that we have the perimeter, so the outside is 22 units. Here's our vertices that we know. What is the value of x? So let's do a little plotting here. So we went -4 up 5. So -4, 5. Then we went over 3, up 5, over 3, up 5. So I can see these are on the same line. They both went up 5. Then we have one that goes over 3 somewhere. We don't know that one. And we have one that's over -4. So I do know it's going to be in line with this. Let me do that in a different color. So I know these will connect. And I know this has got to go straight down. And this one has to go straight down. But I'm not sure where they're going to connect yet. So let's figure out, what do we know? We know the total is 22. So here's side 1 and side 2 should be the same. So I need 2 of the sides. Actually, let's call those the lengths. 2 of the L's. And I need 2 of these to be the same. I need 2 of the widths. And I know the total has to be 22. So there is one side that we do know. We know from here to here for sure. So pause and see if you can find this distance to go over and over and add them together. So to get from 0 over, we went -4, which is an absolute value of 4 units. To go from here to here, we went over how many? Over 3. So we know 4 plus 3 is 7. So our length is 7. We have 2 of these. So we need to figure out 2 times 7 is 14 plus 2 W's equals 22. We need to get W all by itself. So the opposite of adding 14 is to subtract 14. So go ahead and do 22 minus 14. So we're left with 2 W's equals 8. So that means this side and this side put together have to equal 8. So if I have 2 of those, I'm going to divide by 2 on both sides. That means W, the width, should equal 4. So if I go down 4, that puts me right on the x-axis. Oh, sorry, we're up 5. Let me try that again. So I'm going, oh, I can't find grab a new color. We want to go down 1, 2, 3, 4, and I was already at 5. I'm going to go down, and I'll be at 1 now. So I went down 4, and I need to go down 4 over here. So I was up 5, down 4 puts me at 1. So I can see my x is going to be over, so it went over 3. I need to go up 1. Over -4, up 1. So let's just double check ourselves here. So we said that from here to here is 7. That means from here to here is 7. So 7 plus 7. And this side, 5 to 1 to 5 makes 4. And 1 to 5 makes 4. So here is 14 plus 8 is 22. So we just have to do a lot of thinking backwards. We know this side was 7, double it to make your other side. What is left? Well, we know 8 is left, but we have 2 sides. So we had to cut that in half. 8 divided by 2 is 4. So we made this side 4, this side 4. Where did it put that being? Over 3, up 1, over -4, up 1, and we double checked. When I walk around, the answer was 22, so x equals 1. Number 10 wants us, so line segment DE. So is graphed here. Which ordered pair could be the vertex of a rectangular segment with DE as one side and an area of 28? So DE has to be one side. So if we do the other side, will this be 28? So let's figure out how long is DE first. So to get from 0 to D, how many did we go over? 3. To get from 0 to E, how many did we go over? 4. So this side is 7. And we know we have to multiply something by 7 to equal 28. 7 times what? Because we can't change this side. 7 times 4 is 28. So we are looking for anything that is up 1, 2, 3, 4 units. Here's 3 and 1 more. Up 3 and 1 more. We could also go down 1, 2, 3, 4. 1, 2, 3, 4. So either of these, we could make this rectangle, or we could make this rectangle here that have 28. So there are other ways we could make 28. We could do, right, 2 times 14, but we know the side has to be 7. So which of these could it be? Ask you to choose any of them that would fit these different coordinates there. All right, and number 11 tells us a triangle has the vertices. So of -2, -1. So here's A. B is -2, up 4. And C goes over 7, down 1. It wants to know where is A located. So remember, we start here with 1 and work our way around so we can see where is A located. Hey, go ahead and finish your homework. If you have any other questions, please let me know. So I know this is new. We're going to keep practicing and it will be great at it, I promise.